Hello and welcome to Math 212, Calculus 3 online through Monroe Community College. I will be your substitute professor today, Professor Murphy. I will be handling this problem for Professor Seeburger. And today we're going to be talking about level surfaces. Now, as you can see, I've already set up a bit of the problem we'll be working on today, which is from the 10th edition of the Multivariable Calculus textbook. This is from chapter 13.1, and this is problem number 71 we'll be looking at. But before we begin the problem, I just wanted to go over real quickly again what we mean by level surfaces. So on the screen in front of you, you can see I've already set up an equation, f of x, y, and z equals c. Because as we know, when we're talking about a level surface, if f is a function of three variables, here x, y, z, and c is a constant, then the graph of the equation, which you see, f of x, y, z equals c, is a level surface of the function f. Now, what we're going to do is not only will we hand sketch the level surface from the example of problem number 71, but then we'll also verify our answer using the Calc 3D applet that Professor Seeburger was so kind enough to spend many years crafting for us. So, I have opened up my amazing fancy calculus program known as Microsoft Paint, and we're going to go ahead and go through this problem right now. So, the problem specifically stated by number 71 in the 10th edition of the Multivariable Calculus textbook asks us to sketch the level surface of the equation at a given value of c. And the equation we'll be working with is f of x, y, z equals x squared plus y squared plus z squared, and in this specific example, c equals 9. Now, as you can tell, I am quite the expert in maneuvering this high-level calculus program known as Microsoft Paint. Don't worry, to reach this level of accuracy when using a mouse to write math equations takes many years to actually get as good as I am at. So don't worry if you try this at home and notice you're not quite as accurate and your penmanship is not as great as mine. So, how do we go about solving this level surface equation? Well, as shown above, right here, f of x, y, z equals c. Well, down here, we have the f of x, y, z, which is x squared plus y squared plus z squared. So right off the bat, we can then set that equation equal to c. So x squared plus y squared plus z squared equals 9. Now, looking at this equation right off the bat, that these level surfaces are going to be ellipsoids. However, if we're going to draw the actual surface on the axes I have set up on the right, we're going to need to set this up so we can solve for x, y, and z, so we can set the points on the graph and we can go ahead and draw the picture. So to do that, what we're going to do is we're going to go ahead and divide everything by 9. So what that's going to do is leave us with an equation of x squared over 9 plus y squared over 9 plus z squared over 9 equals 1. Now, to plot the points, what we can go ahead and do is we can start solving for each individual variable by substituting 0 in for the other two variables so we can figure out where the intercepts are for that one particular variable. So I'm going to go ahead and move over to this little area here, and we're going to go ahead and change the color so we know this is a little different. Oh, let's see, I've already used blue and red, so let's go with green. So for example, let's say we want to solve for the x-intercept. Well, we'll go ahead and put in 0 for y and 0 for z in both cases, giving us 0. So what that will leave us with is x squared over 9 equals 1. Then we can go ahead and multiply both sides by 9, so we get x squared equals 9. And we get x equals, and remember it's a square root, so it's going to be plus or minus 3. So what we can do is go ahead and head over to the axis we have on the right here, and we can put a little dot over here, and that's going to be 3. And we'll put one over here. That'll be negative 3. Now, if you'd like, you can go ahead and solve for the rest of the variables, but I think we can easily see that in each case here, if we put in a 0 for x and z, we'll get y squared divided by 9 equals 1, which means we'll have the exact same answer as we have for x. And again, if we put 0 in for x and y and solve for z, we'll have the exact same answer for z as we have for x and y. So let's go ahead, head over to the graph here and just fill in the intercepts. So we have 3, or negative 3, 3, and then over here on the y, we'll put a 3 and a negative 3. And what we'll go ahead is we'll go ahead and draw this in. And remember, we want to try to make this as close as possible, which again, considering I'm using Microsoft Paint, might be a minor miracle, but we will do our best here. All right, so as you can see, we have, by hand, it looks like a 2D circle. But what we want to do is really get a look at this in the 3D method. So what we'll do is let's open up CalcPlot 3D and see what this looks like. So we'll go ahead and we'll click to use CalcPlot 3D. We've got our screen, and let me adjust it here so we can capture everything. Now, the problem though is, remember when we're using CalcPlot 3D, it requires the equations to be in the form of z equals. Well, if we go back to here, we can see we don't have an equation set up as z equals. We have this as x squared over 9 plus y squared over 9 plus z squared over 9 equals 1. So we're going to go ahead and need to convert this into the form of z equals. Oh my God, what happened to the problem? No, I'm just kidding. That's just known as, in the movie world, as a quick jump or a crappy edit. So let's go ahead and take what we had before, that x squared plus y squared plus z squared equals 9. And now let's solve it so we can have it in the form of z equals, so we can plug it into the CalcPlot 3D. So if we just do some quick moving around here, what we'll end up with is z squared equals 9 minus x squared minus y squared. Now again, solving for z, so we got to take the square root. So again, we'll have z equals, we have plus or minus, not sure what happened with that square root symbol, but we'll try it again, plus or minus the square root of 9 minus x squared minus y squared. So now that we have that in a z equals form, we can go back to CalcPlot 3D and plot this out. So we'll go right here, and as you can see, I've already filled in for function 1 square root of 9 minus x squared minus y squared. And for function 2, I have the negative square root of 9 minus x squared minus y squared. So we'll go ahead and click both those function buttons. We'll hit the graph button, or in the screen right now, it probably looks like because it's been cut off. Now the other thing we'll do here, and you'll notice, is I've set the axes to 5. The default is usually negative 2 and 2. And actually, since we're here, let me show you if you were to do negative 2 and 2 as your y and x axes, when you actually type the numbers in and have valid numbers. Okay, there we go. We've applied the changes. Now let's go ahead and graph. You can see we get, well, what kind of looks like, you know, 2 little arches, one along the bottom, one along the top. But if you go back to the hand-drawn one we made, it looks like it's supposed to be a full circle. Well, if you think about it, if we cut off our viewing at 2, we're cutting out the entirety of the sphere in this case. So what we'll do is we'll go back to CalcPlot 3D. We can change the axes to 3. Oh, I said 3, not 2. We'll apply the changes. And there you go. Now you can see, wow, that does look like a sphere. And if we go out a little further, and we can make it even more clear that yes, what we're dealing with is a sphere. And if you go back to what we had in the high-level calculus program known as Microsoft Paint, you would see that these match. So, level surfaces are a good way to help visualize functions that have 3 variables and a constant. Now, if you have any questions, again, you can review Chapter 13.1. Remember, this will be on your second exam, which is occurring sometime in April. And if you really need help or any other questions, by all means, please feel free to bug Professor Seeburger. I'm sure he will love to hear from you again and again and again. Again, my name has been Professor Murphy. Thank you very much for the time you have spent with me, allowing me to show you how to calculate level surfaces. Have yourself a great night.